Hi. In this video, I will show you how to create images using Blender and use those in Stable Diffusion and ControlNet to create photorealistic images. I have a simple scene with a car model and a plane as the ground floor. Please note that the car model is composed of multiple parts, which would be necessary to create the canny image. I do not have any lights or world light and we won't need any. Let's adjust the project properties. In the Render Properties tab, click the Color Management header, and change the View Transform to Standard, or RAW, instead of Filmic. I'll use Standard. In the Output Properties tab, set the resolution to match with your project. In my case 512 by 512 pixels will work just fine. Let's create a camera. Click any model in your scene and create a new shader. You can either use the override feature since all the models will use the same shader, or copy the newly created shader to all your models. Let's switch to the shader editor window. Delete the principled BSDF node. Add a texture coordinate node. Add a vector transform node. Change from vector to normal. Change from world to object. Change from object to camera. Add a mapping node. Change type from point to texture. Change X and Y location to -1000 mm. Change Z location to +1000 mm. Change X and Y scale to +2. Change Z scale to -2. If earlier, you choose RAW in color management, you do not need add a gamma node. If you use standard like in this video, you need to add a gamma node and set it to 2.2. We now have a normal map shader matching the OpenGL standard. Normally, a normal pointing to the right is light red. However, ControlNet Normal Bay has been trained on normal maps with the red and blue color flipped. Let's add a few more nodes, separate XYZ and combine XYZ. Connect each to their respective sockets, and add an invert node to the X wire. Let's switch to the Compositor editor window. In View Layer Properties, we will activate the passes that we will need. Combined will be used for our normal map. Z for our depth map. And Cryptomat object for canny. Set levels to 2. In the Compositor window, add an output node. And go to Node Properties to add extra inputs to the output node. Let's do a quick render to see what the passes look like so far. The normal map looks good and we can connect it directly to the input of the file output node. The depth map needs some adjustments and requires some more nodes. Let's add a normalize node and an invert node so the farthest distance is black instead of white. Then we can connect it to the file output node. The Cryptomat pass just need a Cryptomat node, and connect the PIC socket to the output node. F12 or click the button to render the images. Let's review what we have made. Open Stable Diffusion. Since we have created 3 images, we will need to adjust the ControlNet setting to allow multiple ControlNet models. Go to Setting, ControlNet and set Multi-ControlNet to at least 3. Don't forget to apply the changes and restart Stable Diffusion. Let's add our images into the ControlNet units. The order of the ControlNet models doesn't matter. ControlNet Unit 0. Add the canny image, click Enable. From the preprocessor menu select CANI. From the model menu select CANI. ControlNet Unit 1. Add the normal map image, click Enable. Leave the preprocessor to none. From the model menu select Normal Bay. ControlNet Unit 2. Add the depth map image, click Enable. Leave the preprocessor to none. From the model menu select Depth. Type some of your prompts and click Generate. Please note that I didn't add the original make and model of the car as a prompt, as I did not want to influence the result for the purpose of this video. Here are some examples using different prompts, parameters and refinements that we will explore in a following video. Thank you for watching. Goodbye.